Okay, so finally I'm going to solve problem 3 of the exam. So let me find it. It's right here. So it says, a block with a speaker bolted to it is connected to a spring having a spring constant of 20 newtons per meter. The total mass of the block and the speaker is because I'm doing the diagram at the same time. It's 5 kilograms. And the amplitude of its unit motion is 0.5 meters. So letter A says the speaker emits sound waves of frequency 440 Hz. Determine the highest and lowest frequencies heard by the person to the right of the speaker. So, the person. Okay, so here it is. So we know that the highest frequency he will hear, or she, it will come when the speaker is the closest, and the smallest frequency will come when it's the furthest. So it's asking us to use a sound speed of 343 meters per second. So that's what we're going to do. So, okay. We're going to use the formula that states that the frequency heard should be equal to the real frequency divided time the speed of sound plus minus the velocity of the observer, which is not moving in this case, divided by the speed of sound again plus minus the velocity of the object. But we don't know the velocity. But we can use, as energy is not lost, we can use conservation of energy. So we have that 1/2 of the spring constant times x squared equals 1/2 of the mass times the velocity squared. So we have x, which is the amplitude, we have k, which is the spring constant, we have the mass, and all we need is the velocity. So from here we can obtain a velocity of 1 meter per second for the whole system. So what we can do is substitute it here. So we know that there will be two frequencies, right? One, when it's approaching, which is when we will use a positive value. No, when it's going away, sorry, when we will use a positive value. And the other one, when it's approaching, which is when we will use a negative value for the velocity, which in this case we know is 1. So, then we will find two frequencies, sorry. The first one is 438 Hz, and the second one is 441.28 Hz. So these are the minimum and the maximum frequencies heard by the person. Because we just have to change the sign and we know the actual frequency, which is 444 Hz. So the second part of the problem says, if the maximum sound levels heard by the person is 60 decibels when he is closest to the speaker, uh, 1 meter away, what is the minimum sound level heard by the observer? So in this case we know that when it listens the most, it's when the spring is the most expanded, which means that it should equal, like, the length between the distance between the wall and the string and the speaker, sorry, should equal 2 times the amplitude. So we have it right here, 2 times the amplitude and the meter of separation. We know that the distance between the observer and the wall is of 2 meters. My cheat sheet. So, okay. We are first going to identify the intensity of when it is closer to the person, which we identify as 0.1. So we know that 60 should equal 10 times the logarithm of the intensity 1 divided by the intensity 0, and the intensity 1 should therefore be equal to 1 times 10 to the minus 6 watts per meter squared. So this intensity 1 can be substituted in the formula for power, which should be equal to the power times 4 pi the radius squared. Okay. So we can obtain a value for the power when we know that the radius, which is the distance between the speaker and the person, is 1. So here we have a power of 1.25 times 10 to the minus 5 watts. So as the power won't change for the speaker, we can calculate the intensity 2 from this, knowing that the new radius is radius 2, which should be equal to 2. So this second intensity is equal to 2.48 times 10 to the minus 7 watts per meter squared, which, as I explained before, should take place when the speaker is completely against the wall, supposing that it can reach that place, and 2 meters away from the person, which is the radius used in this same formula to calculate, and using this power to calculate this intensity. And from here, we can calculate the sound level 2, which is the lowest or the smallest sound level that will reach this person, because it's when the speaker is the farthest from him or her. So we know that this should be equal to 10 times the logarithm of the second intensity divided by the minimum intensity, and this should yield a sound level of 53 decibels, which is the smallest sound level the person will be reached by. And that's all for the exam. Thank you very much.